So when you have e to the power I theta, I something, then you have introduced cos and sine. Simply what it means is, because our lambda is an I, x is equal to lambda whatever. But this lambda is simply what? I something something. The moment you have an I as a power of e, you've introduced cos and sine. But the I is coming on which term? On this term. So the angle for the cos and sine is omega n, 1 minus that. Are we together? Which means our expression now, when we've substituted it back there, then we'll have x is equal to, there's first of all the first term which is affecting both solutions, e to the power minus omega n t. So the first term relates to the plus. The second term relates to the minus. The first term relating to the plus, we can write it a cos omega n z 1 minus zeta squared, 1 minus zeta squared t plus b sine omega n 1 minus zeta squared t. And from this, you can see now that we have a vibration. If you now draw the characteristic of this, if we draw the characteristic of that, you have something like this. A sine curve is, okay? And a cosine curve is, and so forth. So the difference is, this is starting at 0, the other is starting there. Now if you combine them, you simply get another wave. Are we together? You are simply going to get another wave. So finally, we have something which is going up and down, up and down, up and down. So this is the only case where we experience vibration. In other words, the underdamped system only leads to vibration. Are we together? Yes. Is it clear? Yeah. Right. And in this expression, you see our I is here, which means our I is affecting omega n, 1 minus zeta squared. And that's what comes there. And this is the frequency of the vibrations. That's the natural frequency. And we call this what? The damped natural frequency. I've already introduced it. So we can say omega d is equal to omega n 1 minus zeta squared. And we call this the damped natural frequency. I have a question. Now I want to find the period of the vibration for this system. Who can give me the expression? I want TP. For the undamped case, we said TP is equal to what? 2 pi over omega n, which is what? 2 pi m over k. You remember that? This is for undamped. Now it's damped. Who can now give me the TP? 2 pi over omega d. Okay? Can we all see that? Well, this is the speed at which it's moving. So it's the one that determines the period. It also determines the frequency. Are we together? Any questions so far relating to what we have done? We have found the equation of motion. We have found the displacement. So if you want to find the what? The velocity, you simply differentiate this. Okay? Even the other ones that we found, you simply differentiate, like let's do it for this one, at least. Now you want to find the velocity. What's your velocity? X dot is equal to. Now if you have two terms, y is equal to fx times gx. What is y dot? It's going to be what? Fx g dot x plus gx f dot x. Okay? Or famously, we normally say y is equal to uv. Then we say what? Y dot is equal to uv plus vu dot. Okay? We do that in maths. So we have this term and that term. And we want to, when we want to find the velocity, what do? We differentiate this, and we add to the, we multiply by that. Then we differentiate that, and we multiply by this. Are we together?
Yes.
Let's do that. If we differentiate this, this part here comes there, which means it will be a times that plus that times b. Okay? Then we add to the normal ab. And then when we differentiate this on the other hand, this one, let's call this to simplify matters. Let's call this omega what? Omega d, cos omega d